now in Texas. And Texas is a place where they have a huge problem with supply of fresh water. They have droughts for several years, and most of the water they need to take from wells which contain brackish water. Behind me is a bank of RO membranes. This is a very standard solution to treat brackish well water, and in many cases it works okay. There are problems when you do desalinations. If it was only salt that was in the water, the RO membrane will work quite nicely. Often there is a large amount of calcium, manganese, iron, and there can also be organic matter. And that means that these membranes here will actually get scaled or fouled, and that means that the pressure drop over this membrane will get high, and it's very expensive to run these ones. At the same time, you need to clean them very often, just to be sure you're getting water through the membranes. That is actually a standard problem, and most of the operators of these plants are spending a lot of money keeping these ones running. And we are processing water here to show how to pre-treat the water before it hits the membrane. That we are doing to reduce the maintenance costs, but also to do it without any kind of adding of chemicals. This system here should be able to run for much longer time with much less use of power. Every time you have at least a small amount of fouling of the membrane, the energy cost goes up because of the higher pressure drop. And this side here actually spent more than 65% of the operating costs just to maintain these membranes. That's a lot. And that's something we need to do something about. Our system out here is very flexible, and we really enjoy, we have a climate control container because it is very hot here. But we will now show you how it works when you foul membrane. You can actually do a quite simple small test that will show what and how the water actually will foul the membrane.
Today we're going to run a series of silt density index tests, or SDIs. Silt density index is used to simulate water flowing across a membrane, such as in an RO system. And the SDI can give us an indication of how likely the water is to foul the membrane and how quickly it will happen. The higher the number of the SDI, the more fouling potential there is in the water. And so what we'll do right now is we'll run an analysis of the raw, untreated water, and then we'll compare it to different stages of pretreatment. And this will give us an indication of how effective each stage of pretreatment is in cleaning the water before it enters an RO system. The cleaner the water, the longer an RO system can run in between chemical cleanings, and also the lower the energy cost will be to run the system. So here's the SDI on raw water. We're going to pump this sample of well water through a 0.45 micron filter disc, which simulates the water flowing through an RO system. We measure it at different time intervals to see how quickly the system will foul. And we need to maintain a constant pressure, which will tell us how much the flow has decreased. During the SDI test, we maintain a constant pressure of 30 pounds per square inch, and that lets us see how quickly the flow falls. And that tells us how quickly the filter is fouling. So here we go with the test. This SDI kit measures the flow rate of water going through it, and it does the calculation for us of the actual silt density index. You can see water's flowing Yep. So now our test has been running for nearly 2 minutes, and our flow rate is 531 milliliters per minute, and slowly falling as the filter fouls. Our SDI test is finished now. What we look at is SDI 15 minutes. After 15 minutes, it measures the silt density index of a 100 and a 500 milliliter sample. We have results of 4.2 and 3.6. In a moment, we'll compare that with our pre-treated water. After our SDI test, sometimes it's interesting to look at the filter to see what is collected on it. See, in this test, the pad has become clogged with brown material. Now we'll repeat the SDI test on our pre-treated water. What we've done is we've treated their well water using an advanced oxidation process, and following that, ultrafiltration. And we'll see how that impacts the SDI. Okay, we have our pressure set to 30 psi. Our initial flow rate for this test is just over 700 milliliters per minute. Our SDI test is complete on our pre-treated water. After 15 minutes, you can see our SDI is 1.8. That's very good compared to what the raw, untreated well water was. Now we'll take a look at the filter from the pre-treated water's SDI test. Silt density index is a predictive tool for membrane filtration systems such as RO. It helps us predict how water will behave when it encounters the membrane. Typically, silt density index is used to determine how much additional pretreatment is required before water can encounter an RO system. An SDI of 5 or greater is very unsuitable to membrane filtration because it will cause it to foul very quickly. The energy costs will be quite high. Cleaning will need to be done very frequently. SDI in the range of 3 to 5 will pass through an RO system for a little while, but it will also require frequent chemical cleanings. When we get down below 3, water actually can run through an RO system for quite a long time in between required cleanings, but it will still require periodic maintenance. And then an SDI of less than 1 indicates that water has a very low tendency to foul in an RO or other membrane type of system. If we end up with a high SDI number, as we saw in well water, adding steps of pretreatment can actually help reduce the potential for fouling in an RO system. So as you saw, we went from greater than 3 to less than 2. That's a significant decrease, which means an RO system like this will be able to run for a much longer period of time, purifying a lot more water in between downtime and cleaning. We're here in Fort Stockton, Texas, demonstrating our clean water units. This is a unit designed to provide safe drinking water for people. Today what I would like to do is compare our purified water from our reverse osmosis system with bottled water that you might buy in the store. And to do that, we'll compare conductivity between the two. Conductivity is a measurement of the dissolved ions in the water. So we'll see how they are. This is permeate water from our RO system. And the conductivity reads 12 microsiemens, which is quite low. Now we'll compare that to bottled water that we've purchased at the store nearby. conductivity of the bottled water is 37 microsiemens, 3 times higher than what our reverse osmosis system produces. What that means is our system has removed more dissolved minerals and ions than the water that you can buy at the store. West Texas, under the incredibly hot sun, looking at the amazing difference that just a little bit of water can make in the landscape. Here behind me, you can see flat, dry, barren ground. Just a little bit of scrub brush growing here and there, virtually nothing else. We'll look on the other side of the road though, and we'll see a pecan orchard. Millions of pecan trees. They irrigate them daily. This is just the difference just a little bit of water can make.
To pre-treat the raw water so that it's available to process it in our membrane, we need quite advanced system. What you see here behind me is actually several modules and a lot of equipment. This is necessary to take all the things out you don't want to go into the RO membrane. If you don't do anything and you are sending your raw water from a well, like here in Texas, into the RO membrane, they foul quite easily. We have actually on this side, we are here, get information about they're cleaning the membrane every 3 months. And their operation costs, 65% of that is actually chemicals and utilities for the RO membrane. So keeping the membrane up running is very expensive if you don't do any kind of pre-treatment.